Great. I hope everybody succeeds to connect. I see the chat start to be active. We like this. And hopefully we can have a parallel discussion here as well. We will try also to collect some of your questions, doubts, and exclamations along the lecture so that we can answer them at the end of the lecture. So thank you everybody for joining us. Especially thank you, Madeline, for your availability to give these lectures. We have been following your work for quite a long time here at IAAC, and very happy that you made it to speak in this lecture series. So thank you very much for joining us, Madeline. Why we believe Madeline is so important in the panorama of our work that's happening in IAAC, and generally how we relate technologies and space and humans in our environment, is because she succeeds to engage with the robot in a totally different ways. You've been seeing a couple of lectures here at IAAC related to architecture, manufacturing, making, but also many reinvention about how we can deal with technologies. And she has a very particular take that we love, where she considers robots as creators, not as things. So that we can embody with a personality. And this is quite a fantastic work. Let me introduce quickly her curriculum. So Madeline is actually a doctor. Dr. Madeline Gannon is a multidisciplinary designer, forging a new future for human-robot relations. Her work blends arts and technology to create better ways to live with machine. Known as the robot whisperer, Dr. Gannon is on a mission to take robotics and other advanced technologies open, accessible, and interesting to diverse audience around the globe. She is a World Economic Forum Cultural Leaders and a council member on the Global Council for IoT, Robotics, and Smart City. She also holds a research fellowship at the Carnegie Mellon Studio for Creative Inquiry and leads the research studio Aton. Yes. Dr. Gannon holds also a PhD from Carnegie Mellon University and a Master of Architecture from Florida International University. So a wonderful curriculum that brings us somehow from architectures to another dimension. So thank you very much, Madeline, for joining these lectures, and we look forward for possible future collaboration inside the Master of Robotic and Advanced Construction of IAAC. All yours, the stage is yours. Thank you.
Oh yeah, me too. I'm very excited about that too. I just want to say, to start off, saying thank you for the invitation to this lecture series. So it holds a special place in my heart. When I was finishing my undergraduate degree in architecture in Miami, I applied to IAAC and I got accepted, and I didn't end up going to get a master's there. And so this sort of feels like full circle, being able to have gone, on a different timeline and a different multiverse down a different direction, but be able to still bring back and have this connection with a really progressive institution whose work and pedagogy I deeply admire. So thank you for having me, and I hope what I have to share today is interesting to you all. And on that note, I sort of wear a lot of these different hats. I've been called a designer, a researcher, an artist, a scientist, and I try to embody all of these things as well as wander in between the different boundaries, the different silos of these domain knowledges. But I really started off in architecture. So this is the school that I went to, 2004 to 2010. And it's really the lens through which I see all of the work that I'm going to show across the next hour is really thinking about, I have a deep appreciation for how architecture teaches you to imagine futures that don't exist, communicate them, and then convince people that they should exist. And it's an amazing skill set that has come through true for me in my entire career. And so the work we're going to see today, it's a little different. It's not traditional architecture. It might not even be architecture. So how did I sort of wander off the path of professional licensure towards the more weird and wonderful world of robotics that we're going to talk about today? And at the end of the day, I fell in love with a machine. So I was finishing my master's, and my university got the CNC machine. And it was just completely intoxicating, right? So all of the digital knowledge that I gained in 3D modeling and I finally had an outlet, almost immediate outlet. I didn't have to wait for years in order to get it built. I had a direct outlet to bring that thing out of the digital world and into the physical environment. And that to me was just so intoxicating. It was so cool. And so these machines are usually used for cabinet making. That's like their most common use. That's why they're made in the industry. And so these are some of my first sort of experiments, sort of designing my own tool paths. And like, I'm sure you guys are like run circles around this now, but this was so empowering and exciting for me at the time. And really quickly, I started to get into this territory where I wanted to do things that this machine was not designed to do, like these instead of carving out of wood, I wanted to use this machine to draw. Like I have a 4-foot by 8-foot plotter. How cool is that? And like really quickly, I hit the limits of what that machine would allow me to do, because the people who designed the software for it never in their whole imagination thought that someone would shove a pen up there and use it for drawing, use it for art. And that sort of took away some of the empowerment that I felt, that my creativity and my output was really being bottlenecked by the imagination or lack of imagination of some software engineers that just presumed I'd be using this for cabinet making. And that led me down this whole journey to learn how to talk to these machines. So prior to this, I had never written anything like any line of code. I had no idea how to code. Those little tool paths were like my first experiments in Grasshopper, which is a visual programming language inside of Rhino. And that was really cool. But like I had never really customized my tools besides that. And these are some of my first experiments where I'm actually sort of trying to build tools that existing software didn't allow for. So this is a way to create a little thing that you could 3D print, you could laser cut, or you can CNC route, and it's using physics as a design tool. And like that at the time was something that, you know, it's really specific, it's hyper tailored, but it's not anything that I could get from any Autodesk software. And this was a really nice way for me to begin to understand the underlying abstractions of how to talk to a CNC machine. You know, the way you feed it geometry to sort of get a certain movement or a certain output. I could start to intuit that because I was building my own tools. And at the same time, so this is 2011, and it completely blew my mind. I had no idea that computers could see you. Like, I knew that there's a webcam and there's a thing in there, but I had no idea that computers could begin to reason about what your face is doing, what your hands are doing, where your body is in relationship to it in a very spatial, three-dimensional way. And so that was really, really exciting for me to build these little software experiments that are poking at the edges of that. And it led me down this path of curiosity that I just wanted to reach further and further into the computer and pull out things from this digital world back out into the physical. And so this is a tool that lets you use your 3D hand motion to drape these intricate geometries around a 3D scan of your body. And within this geometry, it's actually a little bit, it's pretty smart. So there's these particles in this 3D scan, these particles in the squid that prevent it from intersecting. So I can have my imprecise hand movements sort of drawn around in a very expressive way. And yet the intelligence of the geometry is sort of embedded in the individual module. These modules also embed the logic of 3D printing. So you don't need to know how to 3D model for 3D printing, which is quite different than just 3D modeling in general. It preserves all of those qualities together. So at the time, a lot of common workflows were to like make something and do some post-processing to make it work. And the technique sort of that I sort of embodied and developed is just make something that doesn't make anything wrong. that just gives you this amazingly fun sandbox that only does things right. And when you pull that out of the digital world and into the physical world, the material things start to happen that are a lot more interesting. And so you get something that, because it's designed for the body, around the body, directly in context of the body, it has these really delicate geometries and touchdown points without, any real need of technical knowledge. And this was a really satisfying experience. But the one thing that I wanted to do is, like waving your hands in the middle of the air to sort of design something. You look really weird. It's not particularly engaging or exciting. And so I wanted to bring that interface out of the computer and into the physical context that it's in. So this next project, I made an interface that basically projects CAD software onto your body as you move around. And so here I'm designing a bracelet for a smartwatch that, again, has these precise parametric fine modeling things attached to this generative open-ended design aspect that, because it's designed on your body, you can, and you know that when it comes out into the physical world, it's actually going to fit. And this is a really fun experience too. I really like making things. I really enjoy the process of making physical stuff. It's where my roots are, and progressively my work has become more immaterial. But at the same time, I'm based in Pittsburgh in the US, and it happens to be the robotics capital of North America. And so you're never more than a couple kilometers away from a big giant beast of a machine. And so I got to learning and experimenting with these tools and really seeing what they can do, what they're good at, what they're very terrible at, and having the sort of space to be open and playful with this. This was a really formative collaboration for me. I was a master's student. This was a visiting artist, and Adi Wagner made this thing. She was about 7 months pregnant with twins, and she made this sculpture that was really talking about the role of unpaid labor that caretaking and caregiving has. And I had never really thought about what robots could do that wasn't making a thing, making a physical thing, making a building, making a car. And this sort of opened my mind to a whole realm of possibilities that I think begin to have more relevancy to a broader world out there. This is a really fun project I did in collaboration with a friend, where I wrote a program that the robot gives you a back massage, because I mean, you guys know, it's terrible programming these robots. It's so frustrating. And so the act of programming, you can release a little bit of tension, release a bit of frustration. You like lean back into it and it pushes harder into you. And when it compiles and when it runs. Well, all this is to say, and these are sort of the projects that I'm going to share today. All this is to say that, working from within this realm of robotics, I didn't really come from the standpoint of automation. I didn't really come from the standpoint of form. I came from the perspective of interaction. And that was something that these machines, you're really just not supposed to interact with them at all, ideally, by the manufacturer's desire. But it's a lot more interesting when you can. And so I'm going to talk about a couple projects where we're bringing these machines out of laboratories, out of factories, and into more cultural environments to really engage with people and help them think about the larger cultural consequences of how this technology interfaces with our lives. Those are just a little sneak peek. But we should start at the beginning and just have some idea of like what I consider, at least, what a robot is. And I make this argument, even if it's just for the duration of this lecture, to suspend your disbelief about what a robot is. And so when we close our eyes and we think about a robot, the image that often comes to our mind are things like the Osimo, like this bipedal technological demonstrator from a company that often falls down. Or you'll think about these science fiction tropes. Or you'll even think about like the amazing research happening at Boston Dynamics, right? When we think of robots, we often look at them almost as a mirror of ourselves. But if you expand that definition a little bit wider to anything that has a mechanical mind and anything that has a mechanical muscles, what you'll see is that there's a lot of different types of species of robots that are already here, walking, driving, rolling, flying amongst us. And so the future is actually now that these machines are living amongst us. And we have this deep drive inside of us, deep inside of us, across culture, across geography, to breathe life into the inanimate, going back to the beginnings of civilization. And when we see sort of modern robotics take hold, we have a lot of examples in pop culture. And it's so interesting to me how these stories of our future from our past, now half a century old, still dictate what we want these machines to do, how we see them in our lives. There's this really interesting sort of nexus and intersection that was happening in these early robots. That at the very same time that there are these experiments in art and technology, cybernetic serendipity, where artists and researchers are coming together to explore what the possibilities are with this new technology. At the very same time, you're having folks do the same exact thing in manufacturing, the same tools, the same technology, beginning to take hold in car manufacturing, in automation engineering. And so a lot of what I think about is thinking about our sort of expected future with these machines, what we expect them to have. And what sort of, perplexes me is in actuality, like the robots that we have in our home, this is way more interesting than what these stories of our future from our past are telling us. Like, no one could have written a script that had a cat wearing a shark costume riding a Roomba being chased by a duckling, right? But that's the more interesting future that I try to push my work towards. And so when I'm thinking about the future and how to situate a project that begins to explore and probe into new dimensions of that future, I always go back to this diagram by the futurist Stuart Candy. It's a really helpful way of thinking about the different kinds of futures there are. So if we're standing in the present and we're looking out into the future, the further we look, the wider the cone of possibilities are, the fuzzier that picture is. And the way that I see it, I see that industry really focuses very narrowly on the probable future that's going to happen. And research looks a little wider at the possible. And the arts are focusing on the preferable, the stuff that sits at the edge of what's possible and what we actually want. And the arts are here to sort of push at that edge and move the centroid of the probable towards the preferable. And so in my work, I work a lot with industrial robots. We'll see a lot of that today. And I find them so compelling and so fascinating and so kind of underappreciated sometimes. Here are these machines. They can, move 7 meters per second. They'll hold 300 kilograms to a sub-millimeter precision, 24/7. These are the attributes, the physical attributes we describe our superheroes with. Superhuman strength, superhuman speed, superhuman endurance. And yet they're sort of like locked away in these factories, living the world's most boring lives, doing short, repetitive tasks over and over and over again. And then the other really interesting thing about these machines is just the visual imagery that they have in our minds and how they have come to symbolize everything that we fear about advanced technology intersecting with society. We fear our own obsolescence through these machines in a lot of ways. And so I find them a really helpful medium to get people to think about, not the futures that we don't want, right? We know what we don't want. Collectively as a society, we've agreed that we don't want to have robot overlords and we don't want to have robot slaves. What's a much harder discussion to think about, to ask ourselves, is what are the futures that we do want? And so that's the direction that I take my work in is to try to find and create these little vignettes of different futures to probe at and see like what can we take from this technology forward into the future to move us towards the more preferable. I'm really passionate about inventing better ways to communicate with machines that can make things. For a long time, industrial robots have been the culprit of automation and replacing human labor. Basically, all the easy tasks to automate have been automated. Now what we're working on is using these tools to enhance or augment human labor. And that to me is very exciting. Industrial robots are really fantastic CNC machines. You put a different tool at the end of the arm and all of a sudden they can do a whole different thing. So in the morning you can be doing spot welding, in the evening you can be doing painting. It's just highly adaptable. Another thing that I'm working towards is finding ways to bring these machines out of factories and into live environments. So onto construction sites or onto film sets. There's chance for unpredictable objects like people to be moving into the environment. That's one of the reasons why I wanted to build the system, to give this robot eyes so that it could actually see me and we can safely collaborate in a shared space. If I'm wearing or if I'm holding these motion capture markers, it knows where I am in space, it knows how I'm moving in space. Now all of a sudden we can give the machine a nuanced understanding of our intention in that space. You can get someone who's never seen a robot before and have them begin to do creative things with just a couple minutes of interacting with the machine. And so fundamentally, what I spend my days doing are convincing machines to do things that they were never designed to do. You know, taking this thing designed for repetition and having it be improvisational. Taking this thing that was designed for precision and have it be expressive. And so that was sort of the impact that I had in programming this robot. And so here we see like me, I'm in the lab. This is me sort of testing and this little robot just like eagerly following me around the lab. And what was challenging for me, or was not challenging, but surprising, is that this robot had a profound impact on me too. That just by the mere fact of how it was moving and responding to my body, we had this connection that I really wasn't anticipating and couldn't explain. And all of a sudden, I felt more like this animal tamer than a roboticist, than an engineer, than a designer, than an artist. You know, just to see this one-ton beast of a machine so eager to come close to me, to follow me around. It was something that I wasn't expecting, and it was something that a lot of people picked up on, that wasn't sort of like written in the code to control the machine. And I had an invitation to sort of bring this robot out of the lab and into a museum. And the request sort of reminded me of these like old Victorian zoos where exotic creatures were brought from around the planet for the entertainment and amazement of the masses. And so that's what I decided to do. I decided to give a robot a 6-month holiday off of their boring assembly line job in a factory in Birmingham in the UK to come live at the Design Museum in London and just exist, just hang out, just be curious about the world around it. And so this is before the museum opened, when they're still installing the ceilings of the finishes on the museum, and the ceiling installers were having some fun with Mimas here. So Mimas is a ABB 6700 robot that usually lives a really boring life. To get her to see the world, we had to use completely different technology, which we developed in-house. And so she's using the depth cameras positioned in the ceiling, looking down, giving a bird's eye view of the entire crowd of people around her. And from that, I can garner really useful information about folks, about how long they've been there, their proximity to her, where their heads are, whether they're short or tall. You know, it can begin to infer, are they a child? Are they seated? Are they an adult? And from that, it built up a preference for Mimas to come visit certain types of people over time. And really, the idea here was to be as minimal as possible for this machine, to have it engage people as if it were born in the wild. So naked, no adornment, no screens, no eyeballs, just using the language of its own body to build these primal connections with the people around her. But here she is brought to life in the museum. What I think is so compelling for folks when they see this machine sort of stare back at them is just how alien this body is in response to their own context, what you know as naturalism around you. And yet there's this definitive connection that when you move and a robot moves back, you can't help but feel. It's tapping into this deep human instinct evolved over hundreds of thousands of years to see, respond, and connect with the animate and intelligent world. It's a really fun day too. This was a workshop we did prior to the museum opening with a group of
Madeline, it seems that we lost your sound and image right at the moment it was becoming super exciting.
All right, maybe, can you see me now? Can you hear me now?
Now, yes, perfect. And we hear you perfect.
Okay, I just switched cameras. Sorry about that.
Thanks. Go for it.
Okay, I'll try to get back on task. But so the previous installation was really looking at one robot amongst a crowd of people, and I was fortunate enough to receive an invitation to explore this idea in the context of the World Economic Forum, which is mostly for policymakers. So really serious people that are very important in their own worlds and are making decisions that impact lots and lots of people. And so what I wanted to show is just what this new reality is for Industry 4.0, when the robots are intelligent, the robots are not under our direct control, and the robots outnumber us. And to hopefully show a bit more optimism for what that future might look like. So there's a lot of things that we do in thinking about not just the design of the interaction, the design of the code, but also the actual physical design that tries to reinforce some of these metaphors that we're going for. So these are 10 EVB 1200 robots, all in an assembly line, basically, on a bed of light, and then enclosed by these highly reflective acrylic panels. What's really unique about this machine, and really all robots going forward in the future, when you think of that outside of manufacturing context, is that they really don't experience the world the way that you and I do. Their minds and their bodies can be separate and distributed kind of anywhere. So we think about the eyes on the machine, but actually we can put them in the ceiling, we can put them in the floor, we can put them in a roaming device. And so this is a way of really exploring how a group of 10 machines can have these pack-like, animal-like behaviors sort of ripple through them as people get close by. And so the sensors here are in the floor, looking up, giving you a worm's eye view instead of a bird's eye view. And the consequence of that is the robots are fairly nearsighted, so you have to get very, very close to them. And you kind of instinctively start to feel surrounded because everywhere in your periphery are robots. Again, this is building some custom software, looking up at us, and we're looking for these very general hallmarks of human body language, where heads are, where hands are, building on the previous work, but with a little more dexterity in how we track and tell the robots how to move. So again, they have a lot of their own decision making here. I build the sandbox for them to be in, but I know that they're not going to throw an error, they're not going to collide with one another, but really amongst that, they're sort of making their own decision and who to go visit, how to visit them, and when they get bored, because that other person just is not that interesting anymore. And this was a really great experience, again, to speak to a different group of people that are used to being in control. And policy in particular is something that is there to put guide rails and to put controls on. But we're entering in a world where control is not the new paradigm for robotics, it's connection. These machines are going out and they're in the wild. And we're not going to be there the whole time to build safe systems or predetermined systems that ensure their behaviors. And so a lot of the work that I do tries to make their behaviors a bit more legible to people, rather than having to look at a screen or be an engineer to understand how these machines move. It was particularly exciting to take these machines into the World Economic Forum, because at one point, you know, oftentimes when I install these things, I get to play engineer, and then once the system is up and interactive, I get to play like biologist. You know, sometimes I feel like Jane Goodall, that's just observing and tweaking how these machines interact with the people around them and engage with them, which is always really fun. But this was a really wonderful experience, again, to take something out of its sort of useful context and try to blend some poetry with the pragmatism around it. And it really just emphasizes that these robots that we're working with, they have bodies and they can communicate. And once they're given a sense of agency and autonomy, that they'll need to communicate with the people that they're engaging with across the public. In my work, I often think back to this like really powerful moment in time in the 1960s, early 70s, where robotics in engineering and robotics in art were still sort of fused together and about to take that first step of divergence. And in my work, I sort of asked myself, like, what if the economic forces that favored efficiency, optimization, and repetition actually worked out in favor of curiosity, companionship, and care? How would our future today look differently if we had 50 years of that type of engineering? And that's sort of where this sort of next phase of my work, which is all work in progress, all just trying to figure it out, building the ship as we sail it. This is the direction that my nose is pointing towards. We've sort of moved from a model of automation towards collaboration, and I see the next step as cohabitation. And that to me is where my interests are beginning to lie, and we like to walk the walk and not just talk the talk. And so I moved in with my robots. We bought a warehouse in Pittsburgh. This 10,000 square feet, which is I did the conversion. 930 square meters of live work space in Pittsburgh, so that myself, my husband, our daughter could all kind of live with these machines and not just visit them 9 to 5 in an office or in a lab space. And so this was a really crazy experience, ongoing experience. We just moved in about 3 months ago, and so I just wanted to share kind of the messiness and that journey, because it's been a bit of a wild ride. And what I'm so excited about is to pull out these projects that have a lot of expensive hardware, need a lot of big space. You need a lot of permissions from companies and people to give you access to those resources. Now I have a space of my own that I don't have to. One project I had to move to San Francisco to do it, move to Boston to do it, move to London to do it. Another project, the one that required 10 robots, I only had space for 2, so I had to do everything in simulation and hope and pray that it worked when I went across the globe and got there to install. And so it's really exciting for me personally to have begun to accumulate these resources and have control and not have to ask for permission to do all the crazy things that are popping into my head. Here's a bit about the buying, renovation, and a process of this building. There was a lot of offices. Lots of dumpsters too. And so this is sort of what you're seeing behind me right now. There's 2 floors or 2.5 floors, and right now we're on the 2nd floor. And so when we originally got the building, it's also really nice to like play architect again. Those are like super satisfying. It kind of sucks to be your own client, I'm not gonna lie. So we got this building, and it was, the 5,000 square feet, and almost all of it was offices. And so the first thing we did was just try to excavate and get rid of and open up the space again. And from there, we sort of added a sort of organizing wall to have a studio space as well as a residential space. And so you can sort of see like the blue area here is what you're currently looking at, this like little square here. And then we have this L of a residence around it. And it's been a really crazy journey. Not only were we the architects, we were also the general contractors on it. We were also the janitorial staff and the security and the office manager for the whole thing. Anything to sort of like get this project done. And so we moved in here about 3 months ago. We have a 1.5-year-old daughter, and for her, being a child of the pandemic, she hasn't gotten a lot of opportunities to socialize with kids, and so she has a robot friend here that she gets to play with. And so this is something that's currently in development with her. You can see the robot sort of pinging right now behind us. But I just want to make a friend for her to swing with. Her swing's currently over in the residential side, but when this thing is sort of up and running properly, we'll merge the two so she has a swinging companion. And this to me it really embodies, you know, the excitement that I have for this next endeavor, where I don't have to ask for permission to hang a robot upside down from the ceiling. And at the same time, I have the proximity to the tools and technology, and they're in the immediacy of my life that I can begin to probe at those edges again of what's possible towards what's preferable, and think about new ways of connecting and care between humans and these machines. And so definitely a work in progress, but again, it's lovely to spend some time with you all today, and share what we're working on and what I'm most excited about. Always open for questions.
Thanks, Madeline. Beautiful. Congratulations. It was a really fresh lecture, full of energy, very personal, and extremely inspiring. I believe there are a lot of people connected online. I see them. So really, really thank you for your lecture, and a couple of notes. I mean, we have time for a series of questions that we can make you. I mean, I would like to keep this personal note that you kept so far with your conference. I mean, I see a series of points that are in general extremely interesting, question mark that you've been launching here and there that I guess are extremely deep also on which is the kind of relationship that we are going to establish with these machines, no? Machines that probably are no longer even just robots. I mean, you've been talking about cognition, but you've been talking about cognition, robotic cognition, towards this capability of activating a new level of interaction, but not control, but connection, you said, and I think it was extremely interesting. With the idea also of using robots as a mirror of ourselves. And I guess this was a very deep thought. And you've been, for all the lecture, I mean, I have to say that you've been playing this role of a robotic biologist and an engineer, but also a very important series of, reflection that you've been doing over ourselves too, no? So I'm wondering, I mean, after seeing all that you made possible, and also this huge variety of applications that you've been exploring, I mean, really, I'm wondering which are the limits that you still see in this interconnection between the physical and digital world, if this is potentially one of the arguments that we could start, and if you believe that I'm afraid to call it robot right now, because yours are not robot for sure, but how you look at those machines, if we can call them like this, are no machine at all, creatures as instrument that can bring and probably even cross the barrier between the digital and physical, and activate a new level of interactivity, no? So I'm wondering for you, which is the next barrier, since you've been breaking so many.
Yeah, I think the biggest limitation that we have right now is as a society, as a discipline as well, we suffer from a lack of imagination, and I think that the technical abilities are rapidly increasing and rapidly democratizing, and figuring out again what those preferable ways that we would like to have these things in our lives is what's really missing, right? Because the folks that are leading the development of this are companies, and so it's industry, and to a lesser extent research, right? But industry is dictating how these creatures roll out into the public realm. And this is a place where architects and urbanists and designers have traditionally had a lot to say and have had a lot of 500 years of disciplinary knowledge to begin to understand and design and coerce the built environment towards these more habitable and equitable domains. So this is why I love the fact that an architecture school, design school is interested in this stuff, right? Because we need more designers, artists, we need more folks from the humanities that are excited about this technology and that have a perspective and a point of view to come and have a seat at the table for how this stuff rolls out. So it's very exciting to see so many people on this talk.
Excellent, excellent. I will ask Alex also to jump into the conversation, but before, let me also give a little bit of space to our audience. I see that Aaron was writing in our chat. Aaron, I see you there connected. Do you want to ask Madeline your question?
Yeah, I mean, I'm curious. I love your work. It's amazing. I think you're doing really, really interesting things that other people aren't, and that's fantastic. So I was curious about if you had thoughts about sort of the relationship between the work that you're doing and the changes that are happening culturally around sort of animals and the natural world. I mean, if we're sort of losing animals daily and we're learning so much about animal cognition, and at the same time that you're sort of experimenting with robots that are more animal-like, do you have any thoughts on the future of sort of robot animal, like how do robots fit into our struggle with the natural world?
I think, yeah, struggle is a great way of putting it. So again, in designing these things, they're very minimal, right? They're technically very minimal too. Now, 1 second. And what these machines are, they're very much a reflection of how we see ourselves. When we're at installation, what I try to hope is for people to think about the technology, but also people to question their own assumptions. For example, like, should we keep robots in cages? Well, why do we keep animals in cages? Why do zoos exist? So for these things that I think that technology and robots in particular, out of all the types of technologies, because they have this level of embodiment that we intrinsically relate to, that they're a good conduit for having these conversations, for questioning how we live now and whether or not we want those models and metaphors to go forward into the future.
Thank you. We have another question from Maciek. Maciek, I also see you connected if you want to.
Hi there. Can you hear me all right?
Yes, we can.
Yeah.
Hi, Madeline. Beautiful work, something very incredibly original. I've never seen anything like it before. That was very inspiring. I was wondering, how do you see the future of cohabitation developing, into what kind of direction? Because here again, I guess we are at the crossroad you've mentioned before with the cone, right? Because there are obvious paths, like, for example, maybe companies implementing this maybe in care homes for old folks, but that's probably some far future where robots help them in maybe day-to-day movement because they are on call 24/7. So I was wondering where you see that path going towards, and what is your next big project that you're excited about in that regard as well? Because it's very exciting. With the whole warehouse, I can already imagine the possibilities with the space as well.
I was gonna say, my next big project is finishing this project. No, those are all great questions, and I guess there's a range of sort of pragmatic answers, whereas like what's happening, what are the trends in industry now that are happening and going to impact us in the next 5 to 10 years, versus what I'm increasingly interested in is leapfrogging over what's those probable things, and so trying to get ahead of the trend and hopefully guide towards more interesting domains. And so what we'll see now, so caretaking robotics is a whole theme of human-robot interaction research. There's companies around it. And a thing that bothers me about caretaking in robotics is oftentimes used as a proxy for a human. So we don't have enough people to take care of other people, so let's just get a robot to do that. And we do have enough people to take care of other people. They're just usually the worst paid jobs, right? And so and they're often done by women, they're often done by minorities, and so it's very, very undervalued. And so, you know, if we had a 6-figure salary for an at-home caretaker, I think there'd be a lot more people lined up to do that. Where I see robotics and caretaking coming into play in the immediate future is a lot of work around soft robotics and wearable robotics. So this idea that you can strap a brace onto your body and have mobility that you had 20 years ago, or have gained some strength back that you used to have, or gain some precision when your hands tremor when you're older. And so it goes more towards living independently longer, I think is that sort of vein. What I've been increasingly interested in is this idea of care as sort of the underlying metaphor for all the stuff we're seeing in IoT. And so IoT, Internet of Things, there's a lot of like the predominant metaphors around automation. I make this little routine, it turns on this, it goes on that, and like it makes your life like moderately better, maybe, or just it annoys you because it doesn't quite work as you think it should. And I don't think that that's the right metaphor for these intelligent, connected, embodied devices that we're living amongst. I think that care is a lot better as this organizing metaphor for what these sort of underlying motivations of these devices should be. And so that's something that I'm thinking more and more about. Like a concrete example is like your IoT connected light or bulb shouldn't really care about their scheduling routine. It should care about the quality of light in the room. And so maybe it turns on, or maybe it shines onto the photocell sensor of your automated blinds that lifts up the natural light on there, right? And for these things to have this understanding of their environment and the network of care in your environment to make a more pleasurable, meaningful, delightful experience of everyday life. That to me is where I see a lot of the potential for this going.
Thank you very much. Thank you.
Oh, no problem, no problem. One more thing is what I've been learning more as like becoming a mom is the sort of therapeutic value of caring for something, right? So we think about these robots as caring for us, but I think there will be value in us caring for them as a cure for loneliness, as a way of connecting through a robot to another entity as well. So that sort of reverses that mirror and has the robot be a recipient of the care rather than the provider of care.
About that, maybe we can jump. Let me give you another question from Gili. I think you are right on the spot with this, with your question. You want to connect with us?
Would I ever? Hello, Madeline. Amazing work as always.
Thank you.
I think my question remains, it's under there in the chat. I am so curious to see how the digital tools you've been using this whole time, the digital interfaces, sensing softwares, did they change in any way the way you see humans? You were able to provoke emotion so efficiently and make people move around. Please tell us.
Yeah, I think a lot of that comes from my training as an architect, right? So as an architect, we're trained to have this hypersensitivity to how people move through space, the relationship that their bodies and motion have to that space. And once I sort of got over the technical hurdle of learning how to talk to computers, learning how to talk to cameras, learning how to talk to robots, I was able to build tools that embed those same sensibilities into these machines. And so I'm beholden to a lot of open source software. I try to develop open source software, give it back to the community. I use a lot of it, and those are the actual like hammers and nails of my tools. There's a lot of open frameworks initially when I started out processing as well, and those creative coding communities were also a harbor in the storm for me, because they don't have a lot of the baggage that a discipline like architecture brings with the sort of very prescriptive value sets that architecture has. And so this was a very liberating experience to engage with the open source and creative coding community, and it helped me sort of find a different direction.
Great. Elena, just from, let me take a question from our student. So Elena from the Master in Robotics and Advanced Construction.
Hi, can you hear me? Thank you. First of all, thank you for this really, really inspiring talk. So yeah, I'm a student of the Masters in Robotics and Advanced Construction with Alba and Alex. And you can see behind me the two ABBs, the UR over there.
Nice.
And the other
nice setup, guys.
Yeah, it's pretty nice. Pretty lucky to have access to all of these. But basically what I wanted to ask is, I just recently gained like familiarity and knowledge with the robots, and I kind of want to keep that momentum going, although it's all ending pretty soon. The year is passing by so fast. So what would be your advice to keep this passion alive, or to not lose the familiarity that we gained through this master program?
That's a great question. I think one of the benefits about a program and an institution like IAAC is the community and the cohort that you have. And so first and foremost is to stay connected with your cohort. And it gets harder as time passes on. You guys will all go in different directions, but you'll be surprised how paths cross over time, over the next decade. And then finding like-minded people as well, and finding community is really important. And like previously, I found my community through the internet and through groups of media artists whose work I admired. So reaching out to people, cold emailing them whose work you admire, asking for conversations, that's totally normal. It's encouraged. You should, there's no map, there's no career map for any of this weird shit we're doing. And so it's on us to sort of, carve the path, and also show others how to walk that direction. And hopefully if there's enough of us sort of wandering out, we'll splay into weird and interesting directions and be able to report back to one another. A lot of things that you can do too is have proxy machines. So you may not be able to have an industrial robot in your apartment or travel with one, but there are drawing robots. Not yet. And not only that, but they're increasingly getting cheaper. So I think about the X-Arm 7, for example, is a great, affordable, safe, collaborative robot, and it's under $5,000, which is still really expensive, but not compared to the EBB ones, But there's drawing robots that you can do. The software to talk to these machines, it's all the same. It's all the same. And we're
actually developing one right now, actually, a drawing robot.
Awesome.
And
awesome.
Alvin, my colleague, and I think Juan are also in the chat.
Yeah, so you guys have to follow up with me, and I want to see it. But those are some things that you can do as we all live kind of nomadic lives, as we all sort of try to figure this out. And the best thing I can give you advice for is to spend a lot of time on documentation. That's the most important part of all of your work. The last 10% is 90% of the work. And being able to clearly communicate what you're doing, why it's valuable, why it's interesting, is going to do wonders for you all. So having a good website, having clear documentation, it doesn't need to have huge production value. It just needs to be out in the world, so you're not the world's best kept secret.
Madeline, you are definitely ready to join us next year. Excellent, excellent. So I have other two questions. If you don't bother. I mean, I see that the audience are really excited and motivated to follow up on this conversation. So David, or I think David Potts was asking.
Daniel, sorry, Daniel.
Daniel, sorry, Daniel. I was wondering about this D. So do you want to go ahead with your question?
Yes, sure. Well, so I posted a little bit about Baby X for Aaron. I actually work with Aaron and Phoebe at the Consortium for Research in Robotics.
With Mark?
Yes, with Mark.
All right.
I love Mark. But I kind of got into this in a weird way, and I come from a religious studies undergraduate background. My master's is in an MFA in interactive digital art, and now I work with industrial robotics doing IoT safety, essentially. That's the research that I'm doing, is your awareness system, but like on a network connected with hopefully multiple robots with multiple tool arms and multiple interactive things. But what do you think about, for instance, with Baby X, the possibility and the real reality that this technology is leading to sentience to a degree? At least how I understand sentience, which is an awareness of your environment and a reaction to it, using like the concept of Umwelt, for example, like the idea of like a tick. All it is its sensory environment. It's what it can handle, what it sees, what it senses, and its reactions are based on that. So at a root level, a tick is just as complex as an industrial robot in that they're sensing the same kinds of sensory inputs and reacting in a way that they're predetermined by evolution or our hand. So I've been kind of petrified, but also super keen. All of my personal work in arts deals with like the manifestation of personal issues within robotics and how we can use robots to kind of communicate complex issues in a way that is empathy building, if you will. I think it's the most powerful tool of empathy. I almost cried just during your presentation. It's such an empathic tool. It's so powerful in a way you can't even fathom. I'm getting emotional.
Oh, don't stop. Keep on going.
No, it's just the way I see, like my thesis. I had the big ABB, the 6700. My only tool arm design was just a human hand. And all it does is approach and trigger a reaction, a personal reaction of trauma. So at what point does that become an encapsulated being? And how do we ethically pursue collaborative projects, essentially? Sorry, I got emotional.
No. It's a great, and well, first of all, thank you for your kind words. I deeply appreciate it. It's very encouraging. The question of sentience is something that's quite interesting, right? It starts to blur the scientific, the theologic, the philosophic into one. And I guess I sort of have my own personal litmus tests for it. That a lot of what I'm particularly interested in is not necessarily the being inside the robot. I'm interested in what it elicits in us. And I think that is very, very powerful. And I think that is enough, right? So we can see that in a lot of religious symbolism. So the cross, for example, has no sentience, but it elicits deep and profound connection from us into the other worlds. And so I see a deep value in that, and it's very underexplored. And I don't really know what to do with it, but it's very exciting. And so, you know, for a lot of these, I go back to the mirror. Like, we're looking for answers about us into these machines. And so I think these robots as a mirror sort of are very capable probes, cultural probes, social probes into looking at how to become better versions of ourselves.
Thank you so much. That's absolutely amazing. This has been amazing. You're amazing. The work's amazing. Thank you.
Thanks, Daniel. Thanks for your energy. Phoebe, do you want to close with your last question and we are done?
Thank you so much. Can you hear me?
Yeah.
Okay, cool. Sorry, my headphones are sometimes finicky. Yeah, thank you so much for your presentation. I'm really interested in, working with these industrial machines. As Daniel also mentioned, I'm working with 6700 or 1600, like with the IRC5 controllers that are obviously limited in regards to processing or the types of things that Rapid or any other industrial code can handle. And what is that balance to be struck between like working within those constraints versus sort of overriding or offloading those onto, say, running it all on open frameworks and just handing only coordinates to the robot? Where is that balance between, like, does the process being embodied in the robot matter, or how do we like find that? I guess how do we find that balance? Is there a argument for working just within the robot and its capabilities?
Yeah, I'm very mercenary about it. So whatever works for me. And you'll notice that for Mimas, the project that was in London, that it moves very jerky. And the issue was that I was able to get EGM, which is this add-on. We're getting deep in the nerd weeds here about ABB specific products. So if I pull me out if I'm going too deep. But one robot that I developed on in Boston had EGM, wasn't guaranteed that the robot in London would, so I had to do everything over TCP/IP, and that's limited to about 4 to 5 commands at the back end. So it's a really slow refresh rate when you want to have interactive interfaces, like minimum 30 frames per second. And so it's 4 or 5. And so that sort of emerged as this kind of jerky, quirky, chirpy behavior in the robot that I just leaned into and had that be a part of the personality of this lifelike creature. Versus the 10 robots, now I'm like bona fide ABB person, so it just gave me a lot of robots with any option that I want. And so those options were all on there, and I had everything. Every robot was just running a server or a client to just receive points being fed over EGM. And you see a lot more fluid movement there. I could use a lot more animalistic simulation there as well to sort of get the types of movements that were appropriate for that particular robot body. And those are all being fed to a single robot brain, which is just my normal PC. And so those, I think that you can't necessarily separate the types of communication and sensing from how the robot moves through the world. Like, same thing for us. If we lost our sight or if we lost a limb, we would operate and move differently in the world itself. But I don't particularly see any need to suffer through Rapid that much.
Thank you.
Thanks. So we should be done. I see that Christopher was launching a couple of thoughts in our chat, but I guess they are more food for thoughts for or invitation to look at us also differently. So Madeline, thanks for your time. Thanks to everyone connected online. Really was an incredible lecture. I'm extremely happy that we pulled it off. So excellent. Looking forward to see you in Barcelona, because we will see you in Barcelona next year. And well, from our side, again, from Barcelona, from Alex and all IAAC, thanks for your time, thanks for your lecture, and thanks for all the audience for being with us tonight.
Thank you all. It's my pleasure.
See you soon. Goodbye, everyone.